In this video, we will discuss the Agile Development Model. Before we jump in, however, let's start by describing a common problem. A business unit approaches the application development team for assistance in automating a set of business tasks. Determined to do a good job and meet the expectations of the customer, the application team decides to follow a formal SDLC, perhaps the waterfall model, to ascertain and meet the requirements of the users. After weeks of meetings and discussions, the team leads and project managers feel that they have a firm grasp of the requirements, so they create functional diagrams, analyze use cases, and implement the requirements using industry-standard coding practices. When the product enters the verification phase and is presented to the customer is dissatisfied. After reviewing the application, the team begins to hear complaints such as, "But it doesn't do this. The old system did it this way," or "What about that?" Does this sound familiar? If you've been a developer for any length of time, you have likely received these types of comments. This can occur when customers are uncertain of their requirements and do not realize what they want until the working software is demonstrated to them. Another common cause is a communication gap between the customer and project team, which can result in incorrect assumptions being made about the requirements. As more time elapses between the requirements phase and when the product is delivered, the likelihood of these problems increases. This brings us to the Agile Model, which helps correct these problems by using less formal documentation and short iterative loops, also known as sprints. The customer and project team are able to review the software at the end of each sprint, which promotes collaboration and working together to refine the requirements. While the average time to deliver in a waterfall model could be months, one sprint in an agile model is much shorter, a few weeks or less. Let's start with the first iteration, which is called Iteration 0. While this phase is handled differently across organizations, Iteration 0 typically allows for the upfront work needed to form the project team, choose platforms and frameworks, and begin thinking about architecture and design. In order to successfully integrate security before the development team starts sprinting and delivering features to the client, Iteration 0 should also complete a number of security-specific tasks. The security SME should be brought onto the project team at this initial stage, who then provide secure development training, review secure coding practices, and cover the framework's security features. The project team should be made aware of any security requirements, regulatory laws, and privacy constraints. In addition, a rough attack surface analysis can be used to build a high-level threat model, which helps define the initial security architecture. Completing these security steps up front during Iteration 0 allows for the design, security architecture, and risk analysis to be refined and maintained throughout each sprint going forward. After Iteration 0 has been completed, the development team is ready to begin looping through each sprint and obtaining feedback from the customer. It is important to remember that each sprint is intended to be lightweight and quick, which creates a trade-off between agility and security. Let's illustrate. Consider a scenario where static and dynamic analysis scans are run against a large application on a periodic interval. The scans produce a report with hundreds of pages and thousands of items that need to be researched by the security SME. After spending several weeks validating the results, the security SME delivers a report with hundreds of confirmed vulnerabilities. Not only is this discouraging to the development team because valuable resources will be spent fixing the issues, but the contents of the report are outdated. Additional development sprints have likely been completed during this time frame. As you can imagine, this creates an endless cycle where security is always 2 steps behind the development process. For this reason, the security SME must adapt to the Agile model by providing continuous security for each sprint through integration and monitoring. Several security checkpoints can still be completed during every iteration without slowing down the development team, while other checkpoints are only needed prior to a production release. Application design, attack surface analysis, threat modeling, and security architecture reviews should still be done during each sprint. However, the security SME must adjust these tasks to be as lightweight as possible. For example, some organizations choose to replace a cumbersome threat model with a short questionnaire or quick technical meeting at the beginning of the iteration. The most important assets, threats, and high-impact risks can be reviewed and documented as necessary while removing the overhead of utilizing a complicated threat modeling process and associated software. Once the process has been adjusted to fit the Agile model, the project team can quickly apply the incremental changes to the threat model and move on to their development tasks. In addition, the security SME should help the development team write unit tests for security-specific cases, which can be automatically executed and monitored by the development team. Static analysis tools should be installed on each developer's laptop, which presents feedback to the developers as changes are committed to the source control repository. The security SME should identify high-risk components such as authentication, password management, encryption, and validation libraries. These components should be modified only by experienced developers, monitored on the build server for code changes, and reviewed by the security SME for vulnerabilities. Dynamic analysis tools should be configured to continually test the software running in the development, staging, and quality assurance environments. The results of each automated test are scoped down to the code committed during each short sprint and continuously monitored by the project team, making security agile and easy to manage. Any security issues identified during the security tests are added to the product backlog, which is a prioritized list of bugs, enhancements, and requirements. Items in the backlog are typically written as user stories, so the security SME may need to assist the project team with writing, testing, and reviewing any security-specific functional, abuser, or abuse stories. Sprints are wrapped up with 2 meetings at the end. The first meeting, the sprint review, simply reviews what was completed and what wasn't. Completed work is then presented to the customer for review. The second meeting is the sprint retrospective. Each team member is asked to provide his reflections on the just concluded sprint by answering 2 questions: what went well and what could be improved for the next sprint. At this point, the security SME should examine the current state of the application's security. How many security issues were addressed? What security bugs or stories are still outstanding? What new risks were added to the product backlog? Do any security gaps need to be discussed to improve the software during future sprints? These discussions will help continuously improve how security is performed in the Agile development lifecycle. After any number of secure iterations and feedback loops with the customer, the project team reaches a point where the changes are ready to be released to production. At this point, the security SME should determine how the application will be monitored in production, review incident response plans, and conduct a final security review. Depending on the severity of any known application risks and the risk tolerance of the organization, a decision will be made on whether to approve the production release or perform additional security testing. Expert security source code reviews and penetration tests may also be scheduled outside of the development sprint cycle to find any security issues that may have been missed by the automated tests and other checks done during each sprint. Any problems identified during these tests are added to the product backlog and, if necessary, addressed during a dedicated security sprint, aka a hardening sprint. After the security sprint is completed, another penetration test may be required to validate the fixes before finally approving the production release. This brings us to the end of the Agile development model. It is important to remember that the security SME must be part of the project team, embrace the Agile lifecycle, and help the other team members understand why security is important. Security must adapt to Agile with tools that provide continuous integration and feedback for improving future sprints. A secure Agile lifecycle should empower the team to do their work and deliver a stronger, more secure product.